Hello, in this video we solve some examples on double integrals. The first example, they give us some integral and they ask us to sketch the region of integration and evaluate the iterated integral. Okay, so if you have such integral, you may evaluate it without the region because you already have integration limits. Make sense? But they ask us to do that, so let's do this. We can see the region of integration right in here and in here, okay? So for the first integral, I see the y is in between 0 and 9, and x is between y minus 9 and less than or equal to 0, okay? And for the second integral, y again between 0 and 9, and x is between 0 and 9 minus y. So basically, in order to see the region, we need to sketch two straight lines, this straight line and this straight line. All right, let's do that. So we have x or y plane right here, x, y, 0. Suppose that I have 9 in here, and so I have negative 9 here, and here is 9, okay? So the first straight line passing through 0, 9 and negative 9, 0. So I have this straight line. This is y equal to x plus 9 right here, okay? For the second one, I have y equal to 9 minus x. So I can see that also pass through 0, 9 and 9, 0. So this is this straight line, okay? Now look at this. For the first case in here, x less than or equal to 0. So that means we just consider this part, okay? And y is in between 0 and 9. So don't forget, we have y in here, okay? So I pick the one which is less than the straight line together with these conditions. So my region look like this. Makes sense? Similarly, for the second case, when you have the straight line y equal to 9 minus x, and y is in between 0 and 9, but you consider for x greater than or equal to 0, so you just consider this part and the one less than or equal to that, right? So the second one looks like this. And you compile two regions, you get your region of integration. Now let's evaluate our integral. But I will do that just for one, okay? You do for the second. I might copy in here. Integral from 0 to 9, integral from y minus 9 to 0, e to x plus y, dx dy. Okay, so we integrate with respect to the x first, right? So you might think, yeah, that is nothing but x plus c. You know, you look at c as y as a constant. So the antiderivative of this function is just ex plus c, right? So that means ex plus y. I have ex plus y evaluated from y minus 9 to 0, integral from 0 to 9 dy. Okay, and then I have this is equal to integral from 0 to 9. You plug 9 y minus 9 into this, into the position of x, you get e to 2y minus 9. And when x equal to 0, with the negative right here, when x equal to 0, you get e to the y, and then you get dy here, okay? And you practice into two integrals. The first one is from 0 to 9, e to the y dy, and minus 0 to 9, e to 2y minus 9 dy. This is pretty easy because antiderivative of e to the y is just e to the y evaluated from 0 to 9. The second one, you can do substitution, or you can write directly antiderivative of this. So I can write in here that is 1 over 2 e to 2y minus 9 evaluated from 0 to 9. And the last step is just plug 0 and 9 into these two functions. Okay, let's move to the second problem. They ask you to set up integrals for both orders of integration. Use the more convenient orders to evaluate the integral over the plane region R. Okay, so you have the integral. The region R is a sector of a circle in the first quadrant bounded by this, and this, right? So we have the first quadrant and those curves. We have to graph them. I have x or y plane. In the first quadrant, the first curve is what? Is y square equal to 625 minus x square, or that is x square plus y square equal to 625. 625 is, I guess that is 25 square, right? So this is nothing but, you know, the circle, center at the origin and radius equal to 25. Okay, so that is the first one I have right here. The circle here is 25, here is 25. Next one, 4x minus 7y equal to 0. Okay, so we need to graph 24x minus 7y equal to 0, or y equal to 24 over 7x. Alright, so when x equal to 0, y equal to 0, x equal to 7, y equal to 24. So let's say that somewhere in here, right? Okay, so I have this straight line. Okay, we may find the intersection point. That is not a big deal, and of course we need to do that. Y equal to 0, that is the x-axis. Okay, so you have this one, the circle right here, and then the straight line, and our region bounded by those curves. Okay, so we need to find, we need to find the intersection right here. In order to find that intersection, we need to solve the equation 24. No, we need to set this 24 over 7x equal to square root of 625 minus x squared. Alright, so I will set them equal. I have 24 over 7 equal to x in here equal to square root of 625 minus x squared. Let's square them. I have 24 square x square equal to 7 square times 625 minus x square. You solve this equation, you get x square equal to 49, okay, or x equal to plus minus 7. Of course, you pick x equal to 7 because x is greater than or equal to 0. All right, so this is 7. And if you want, you can find, the y coordinate. You just plug 7 into this straight line, you get 24 right here. Okay, so we have intersection. That's good. We have the region. That's good. Now, let's write the integral. Our integral is integral of x over r. You see that? So we have the following one. R x dA, right? So you have to write in two forms, dx dy or dy dx, and then you have to pick one of them to solve the integral. So for the first integral, you will have the following one. You fix y, right? So each time when you fix y, you make some horizontal line in here. You can see this horizontal line intersects with the straight line and the circle at 2 points, right? And this is the interval of x. You have to find intersections. Makes sense? And how the y change? The y change from where? From 0 to 24, which is the highest point of the region. So I will have the following one. Integral outside from 0 to 24, okay? The inside, I need to find two intersections. Let's do that. For the first one, you have y equal to 24 over 7x. From here, I can solve for the x. That is just 7y over 24, right? So that is the first point here. 1. The second one, I need to use the equation of the circle. From the equation of the circle right here, I can solve for the x, right? I solve for the x, I get x squared equal to 625 minus y squared, and x equal to square root of 625 minus y squared. I have the second point. So I can see that the guy in the first position here is less than the guy in the second position, right? So the integral will go from where? From 7y over 24 to square root of 625 minus y squared, and here I have x. Okay, that is the first integral. Now let's consider the second form. When you change the order of integration, in this case you fix x, right? And then you integrate with respect to the y first. So I will not need to make the horizontal line. I need to make the vertical line, right? Look at this. So in this situation, I need to consider two cases. The first case, when my vertical line is corresponding to the x, which is in 0 and 7. You see this? Because in this interval, the horizontal, the vertical line intersect with the straight line. Makes sense? But when x is bigger than 7 right here, so that vertical line will not intersect with the straight line. They will intersect with the circle. Makes sense? So you need to break the integral into two integrals. The first one, when your x goes from 0 to 7. Okay? And the second one, when your x goes from 7 to 25. Makes sense? So for each integral, you have to find integration limits. For example, when x between 0 and 7, you can find the intersection easily. That is your y already in here, right? 24x over 7. So the y will go from where to where? Go from 0 to 24x over 7. Right? And here you have x dy dx. That is the first one. For the second integral, the y also go from 0, right? But to the circle right here. So I see the circle is nothing but, square root of 625 minus x squared. And here I have x dy dx. Makes sense? Alright, now your choice. You can pick one of them and evaluate the integral as you want. But in my case, I think I would pick the first one. It looks easier for me. Okay? Because when I integrate the function x right here, I will have x squared over 2, right? And when I plug, square root of 625 minus y squared and 7y over 24, I will not have square root anymore. So I think it would be easier. Agree? So I will leave this to you. Please solve that and send a solution to me. All right? In the next problem, you need to write a double integral and use that double integral to find the volume of this solid region. Okay, so this problem is very similar to the one in the lecture, in my video. But anyway, I will solve that again, okay? If you look at this picture, you would think, yes, that is the equation of the surface, right? Alright, so where's the region of integration? The region integration is right here. This is the straight line y equal to x, right? And here is the x-axis, this is the y-axis, and y go from where to where? Y is in between 0 and 4. Of course, you may think, yeah, x is also between 0 and 4, right? Because, you know, the straight line is y equal to x. Make sense? So the region of integration is nothing but the triangle x0, y, x equal to y, y is from 0 to 4 right here. Okay, we already have 0. So basically the region is this. Okay, so we apply the formula of the volume. What is the formula of volume? We know the volume is equal to double integral on R, right, Z dA, right? And the Z is 16 minus y squared dA. Now, the next step is to rewrite this as an iterated integral. So we have two choices, right? We can rewrite in the order dx dy or dy dx. Let's do both them, right? And then we pick one of them to solve. All right, if we choose dx dy, we fix y. We need to find the interval of x right here. So x basically go from where to where? From 0 to the y, because this is the straight line y equal to x, right? So I have integral, y goes from 0 to 4, x go from 0 to y, and the function here is 16 minus y squared. That is the first one. The second one, I fix x. So let me erase the horizontal line. I fix x. I need to make the vertical line. Okay. I need to find the y right here. Y will go from where? If this is x, this is also x, and y go from x to 4. So I have x goes from 0 to 4, y go from x to 4, and here we have 16 minus y squared. I think both integrals are pretty easy enough. So let's pick the first one, right? Let's pick the first one and solve it. So I have the following one. I integrate with respect to the x. 16 minus y squared is as a constant. So I have integral from 0 to 4, 16 minus y squared. In here I have x evaluated from 0 to y, right? And then dy. This is equal to 0 to 4. I plug y and 0. At 0, this function is 0. So at y I have 16 minus y squared times y dy, right? And that is 0 to 4, 16y minus y cubed dy. I hope that you can finish this problem yourself. Just use the power rule. Agree? The last problem for today is we need to set up integrals for both orders of integration. Use the more convenient order to evaluate the integral over the plane region R. So that is almost similar to the second example, right? But with different functions and different region. Okay, let's do that. So I need to figure it out about the region. Y equal to 0, y is square root of x. all x equal to y squared and y is 49, right? I need to graph all those. X, y, 0 in here. X equal to y squared, so I would have the following. Okay, that is parabola. X equal to 49, so y is 7. Let's say this is 49, this is 7, right? Y equal to 0, that is the x-axis. So basically our region is this part. Okay, so once we have the region, we just go ahead to rewrite the integral in terms of iterated integrals. Okay, I will write both, and then we pick one of them to solve. So I will write the order dx dy. Okay, I need to find integration limit in here, y over 1 plus x squared. If we fix y, we know that y goes from 0 to 7. Right? Because we need to find this intersection point. Don't forget that. That is 49. So that's why you plug 49 into the equation. Y equal to square root of x. You can find y is just 7. So y go from 0 to 7. And x, we fix y. So I make some horizontal line. X goes from this point to this point, right? But what is this? This is just y squared. Is that correct? Because if you have x in here, if you have y right here, so the x coordinate is y squared. That is y squared. Make sense? Alright, so x goes from y squared to 49. That is the first integral. If you want to use the order dy dx, we can figure it out. 1 plus x squared in here. So we fix x, right? If you fix x, let me erase this, erase this, erase this, erase this. I have to make vertical line, right? Because we fix x. So y goes from 0 to square root of x. If this is x, makes sense? So y go from 0 to square root of x, and x goes from where? From 0 to 49. Okay, so now if we choose one of them, let's choose the easiest one. Okay, among them, I would choose the second one because it looks easier for me. You know why? Because if you integrate with respect to the x first, you have to handle 1 plus x squared. I don't like that. So I want this combination y dy. Agree? So let's solve that. I have the inside integral is nothing but y squared over 2 1 plus x squared. Evaluate from 0 to square root of x, and then I have the x right here. You see, because antiderivative of y is y squared over 2. That's it. And you plug square root of x and 0 into this integral. At 0, the function is 0. At square root of x, you have square root of x squared. That is just x, right? So that is integral from 0 to 49 x dx over 2 1 plus x squared. I hope that this integral is familiar to you. At least you can see the combination x dx and 1 plus x squared, right? So I put u equal to 1 plus x squared. I get du is 2x dx. Okay. I can change the integration limit right away if you want. Let's say when x equal to 0, u equal to 1. When x equal to 49, u is equal to 50, right? And then the original integral will be. But before that, you need to solve x dx equal to du over 2, right? And then I can rewrite the original integral. That is equal to integral from 1 to 50. X dx is du over 2. I have 2 out there, and 1 plus x squared is just u. right? What's that? That is 1/4 ln of absolute u evaluated from 1 to 50. So you plug 50 and 1 into this function, you got 1/4 ln of 50, because ln of 1 is just 0. And that is the volume of our solid region, right? And this is the answer of our problem. Okay, so I hope that this video is useful for you to do self-review, and I hope that you do well on the test. Bye-bye.